Okay, so you guys, the last lesson that we have to get through with solving systems, it's going to be on page 633, so make sure you're on page 633 in your workbook, and it's a method called elimination. So box in elimination. When we solve systems, so a couple of things just to review that I want you to write at the top of your page. When we solve systems, how many graphs am I giving you, or how many equations will you always get? 2, right? So you're always going to get 2 equations. There are 3 methods to solve systems. And the first method was what we did 2 days ago, and that was graphing. And when you graph lines, and the solution is where those 2 lines intersect, right? And that solution is going to give you an x coordinate and a y coordinate. But that's the solution when you graph. An alternate way is what we did yesterday, which was called substitution. And that's where we solved one of the systems for one of the letters. So we said like y was equal to, and we plugged that into the second system. So that's called substitution. And substitution gives us an x, y coordinate. So the same thing. The third and last way we could solve systems is a method called elimination. And again, we're going to get an answer that's going to be a coordinate. On your unit exam on Monday, your very last long answer, it is going to give you 2 lines, like it's going to give you 2 equations, and it is going to say algebraically solve. Algebraically solve means you can either do substitution or elimination. And what's going to happen is by the end of today's class, or by the end of this lesson, you will be really good at looking at your systems and telling me substitution what you should use, or is elimination what you should use. So you'll get really good at being able to figure this out. Okay, this is your notes here. And again, star that this is your notes, but we'll go through this. This is just if ever you forget, how did she set up elimination? Okay, so let's look at these 2 examples. So we've got these 2 examples here. And if you got this on your test, you would not want to do substitution. And the reason why you wouldn't want to do substitution is because in order to do substitution, you want to solve for one of the letters in one move. And we can't do that. Do you guys agree with that? We can't do that. So if we can't solve for one of the variables in one move, we're not going to do substitution, we're going to do elimination. How you do elimination is as follows. You line up your x's, you line up your y's, you line up your equal signs, and you line up your constants. So everything's lined up, and you put a bar underneath it. We are going to figure out if we're going to add or subtract these 2 systems together, and one of our variables is going to be eliminated. The variable, you guys, that we're going to eliminate is the y's, because I've got a 7 and a 7. So what I need to figure out is, am I going to add these 2 systems and my y will disappear, or am I going to subtract these 2 systems and my y would disappear? So it's just sort of like guessing and checking. If I added 7 plus -7, let's see what would happen. The y's disappear. Watch what happens if I said, okay, maybe I should, like, is it subtract? Does she want me to subtract these 2 systems? So if I subtracted, you would type in on your calculator 7 minus -7. And 14 would come up. You want to choose the one where you eliminate a letter. So we would add, okay? So we're going to add these 2 systems. So watch what happens when we add. 2x plus 3x gives you 5x's. 7 plus -7, it's gone. This guy eliminates. That's what elimination is. Bring down your equals and add those two numbers. 13 plus 2 is 15. Rebecca, what letter am I solving for? X. What do I have to do to get X? Sorry, divide 15 by what? By 5. Get rid of that 5. And I've just solved for X. X is equal to 3. Once you solve for X, we now have to figure out what Y is, right? So you say to yourself, okay, how do I figure out Y? You are going to plug that X into either of these systems. I tell students to look at the systems, and sometimes one looks a little bit easier than the other. You're going to get the same answer. I always choose the system with no negatives, if I could. So I'm going to plug it into the first one. So this first system, 2 times 3, because X is 3, plus 7Y is equal to 13. 2 times 3 is 6, plus 7Y is equal to 13. Subtract your 6. 7Y is equal to, what is 13 minus 6? What do you guys get? 7. What does Y equal? Y is equal to 1. My answer is 3, 1. If this was the exam question, what it would say is algebraically solve. So we've just algebraically solved, right? So it's going to be like about 3 points for algebraically solving. And then it's going to say verify, and you're going to get 2 points for your verification. So in order to verify this, we must put that 3 and the 1 in both original equations. So one of my systems was 2x plus 7y is equal to 13. And the other system was 3x minus 7y is equal to 2. And we need to put them in both to see if left-hand side equals right-hand side. It has to verify for both. So x is 3, y is 1. So 2 times 3 plus 7 times 1. 2 times 3 is 6, plus 7. 6 plus 7 is 13. It verifies in my first system. Plug it into your second system, see if you got the same answer. Does it get 2 on the right-hand side? So 3 times x, which is 3, minus 7 times y, which is 1. 3 times 3 is 9, minus 7. 9 minus 7 is 2. Left-hand side equals right-hand side. It verifies. Okay? Let's look at class example number 2. So again, if I gave you this on Monday's test, you're going to say to yourself, okay, she said the word algebraically, which means either elimination or substitution. Is this a good one to do substitution? No, because I can't solve for one of the letters in one move. So if you saw this, you'd say, I'm going to eliminate. I'm going to use elimination. So elimination, you line up your x's, you line up your y's, you line up your equals and your numbers. What letter do you think I'm going to be eliminating here? The x's, because I've got a 2 and a 2. So it's the x's. Then you just have to decide, am I adding or subtracting the two systems? If I put a plus here, how many x's would I get? 4 x's. So it is not adding. This is going to be a subtraction. 2 minus 2 eliminates my x's. Elimination is getting rid of one of your letters. 6 minus 3 is 3y. Is equal to 6 minus 4.5 is 1.5. From here, we're now solving for y. So divide both sides by 3. And we're going to get y is equal to 1.5 divided by 3 is 0.5. You then take your value and you say it needs to go into either the first or the second system. You'll get the exact same answer if you put it in both systems. I'm going to put it into the first system because I've got a decimal in the second one. I could probably do the first one in our head, right? So let's plug it into the first system. And let's see what x is. So 2x plus 6 times y, 0.5, is equal to 6. 2x plus 6 times a half is 3, is equal to 6. Get rid of that 3. 2x is equal to 3. Divide both sides by x, and you would get x is equal to 3 over 2. Does anybody know what that is as a decimal? 1.5. You're thinking of 2 over 3. Yeah, so this would be 1.5. So my solution as an ordered pair is 1.5, comma 0.5. So out of 5 marks, that would get you 3 out of 5 marks. And then your additional 2 marks would be for verifying. So we're not going to verify. But if you plugged it 1.5 for x and 0.5 for y, in both systems, it would verify. Okay? Okay, flip your page. We're going to do this next one in 2 ways. So let's say you saw this question on your test. Can somebody tell me, you may choose to do this by substitution, which system, system 1 or system 2, could you solve for one of the letters really easily for? It would be in 2 moves, but you could probably do it in your brains. So Piper, what do you say? The second system, and what would you actually solve? What letter? The Y. Yeah. So you guys, let's just actually quickly review substitution, right? And then we'll do this exact same thing with elimination. So if you got this one on your test, you might say, I want to solve for Y. So I'm going to bring the Y to the right-hand side to make it positive. And I'm going to bring the 22 to the left-hand side. And what I would get would be y is equal to 4x minus 22 if we were doing substitution. Then you would box in that 4x minus 22. And where would I put this? In equation 1. And which letter does it go in for? It would go in for, does it go in for y or does it go in for x? It goes in for y. Yep, so let's solve this, pretending we're doing substitution. So we would have 2x plus 3 times y, which is 4x minus 22, is equal to 4. Okay, because some of you might choose to do this question by substitution. So we would get 2x plus 12x minus 66 is equal to 4. How many x's would I have when I combine? I'd have 14 x's minus 66 is equal to 4. Add 66 to both sides. 14 x's is equal to what, you guys? 70. And how many times does 14 go into 70? Check on your calculator. So 70 divided by 14, 5. Okay, we just solved x using substitution. Now, to get y, where would I plug this 5 into? This guy right here, right? It's got y ready for us. So y is equal to 4 times 5 minus 22. Y is equal to 20 minus 22. Y is equal to negative 2. So my answer is 5 comma negative 2 by substitution. Let's do the exact same thing, and now we're going to do elimination. So you need to find like just a place to write this. let's write our two systems again. So 2x plus 3y equals 4. And we got this system here. Okay, so you're going to say to yourself, let's see, I got my x's lined up, I got my y's lined up, I've got my equals lined up, and I've got my numbers lined up. And then you're going to say, but nothing eliminates with my x's, and nothing eliminates with my y's, right? So here's what you could do if that ever happens. What you could do is you could say, what could I multiply this entire thing by if I wanted to eliminate my x's? What could I multiply this first system by? By 2. If I multiply this first system by 2, I'm going to have a 4x and a 4x. Or another way you could do this, let's say I wanted to eliminate my y's, you guys. What would I multiply this entire second system by? By a 3. Yeah, and you will get the exact same answer. So let's do the first system. Let's get rid of our x's. So let's say my first system, I'm going to multiply everything by 2. What you would get is you would get 4x's plus 6y's is equal to 8. The second system, I'm not doing anything. 4x's minus 1y is equal to 22. Now we are set up for elimination. You're going to do your bar. Do you guys think I will add or subtract these two systems? I will subtract because I want to get rid of my 4's, or sorry, my x's. So I would subtract. So 4 minus 4 cancels. You got to be careful with this. It is 6 minus negative 1, right? So if you need to, 6 minus negative 1, 2 negatives is going to give you a positive, so we'll get 7. So 6 minus negative 1 is 7y is equal to 8 minus 22. And we get negative 14. Divide this by 7, divide this by 7. Y is equal to negative 2. Is that what we got when we did substitution? Yeah. So y is equal to negative 2. Now to figure out x, you say to yourself, plug in that negative 2 into any of the original systems, right? So I got to plug in that y is equal to negative 2 into the original systems. Do you guys know which one I would choose? Do you guys think I would choose 1 or 2? I'm going to choose 1. Yeah, it doesn't matter. I just, for whatever reason, I worry that students are going to mess up with the negative here. So I would say, okay, I'm going to choose this guy. 2x plus 3, y was negative 2, is equal to 4. 2x minus 6 is equal to 4. Add 6 to both sides. 2x is equal to 10. Divide both sides by 2. X is equal to 5. We get the exact same answer. You guys good so far? Yes, Piper. No, because I plugged it into the original system. So when you're plugging it back into you don't have to worry that we multiplied everything by 2. You don't have to worry about that. You plug it back into the original system. And actually, Piper, if you would have plugged it into this system here, you would have gotten the exact same answer. So yeah, you don't have to do that at the end. Yes. Okay, so if we would have plugged it into system 2, see, this is why this system makes me a little more nervous. How you'd plug this one in, it would be 4x minus, and then I would have to have negative 2, because that's my y, is equal to 22. That would be 4x plus 2. 2 negatives give you a positive, is how you do that. Yeah, that's why I would never choose the negative one. Okay, so you guys, let's look at this one. Last one. Okay, so let's write this down. Write it sort of off to the left because we're going to be multiplying. So 5a plus 3b is equal to 3. 3a minus 7b is equal to 81. So you look at this and you say, I can't do substitution. Like that would be a mess, right? There's no a or b that I could solve for in one move. It's not going to be substitution. So then you say it's got to be elimination, right? And I've got my a's lined up, my b's lined up, my equals, and my numbers. However, you say, well, what the heck do I multiply like this by to get the same answer here? And what do I multiply, like what could I do, right? So what you do in this case is watch, there's a trick. Let's say we're going to eliminate the a's. What I'm going to multiply this top guy by is a 3. If I'm going to eliminate the a's, I'm going to multiply this top system by a 3. How many a's will I have? 15 a's. What do you think I'm going to multiply the second system by? A 5. Okay, so we got to do some work for this. So we're multiplying the first system by a 3. So we get 15a plus 9b is equal to 9. Then we'd get 15a minus, what is 5 times 7? 35b is equal to, yeah, so 81 times 5. I'm going to want that on my calculator because we're going to, oopsie, not negative. So 81 times 5, 405. Is that what you got, Hermes? Okay. So this should be 405. Am I adding or subtracting my two systems? Subtracting. Because I got to get rid of those a's. The only way I could get rid of those a's is by subtracting. The a's eliminate. Now it is 9 minus negative 35. So do that on your calculator if you need, right? Clear what you have. 9 minus negative 35 is going to give me 44a is equal to 9 minus 405. Negative 396. Divide both by 44. A is equal to negative 9. Oh yeah, I was like, what? Sorry, yes, B is equal to negative 9. Oh yes, there's a mistake here. Let me change that. This should be B. B is equal to negative 9. Now what I have to do is I got to figure out A. You get to choose system 1 or system 2. Where am I putting it? System 1. So system 1, 5 times A plus 3 times negative 9 is equal to 3. 5A minus 27 is equal to 3. Add 27 to both sides. So get rid of that negative 27. And we would get 5A is equal to 30. And when you divide by 5, what does A equal? A is equal to 6. So that's A, and that's B. And that is how you do elimination. Kieran, yes. Yeah, you know what? X and Y so that you could figure out how to plot it. So on your test, it's definitely X and Y. This, though, because we're not graphing anything, we could do A's and B's. So in your homework, I might give you some A's and B's because this is how you would do it if you got A's and B's. Yes. No, so for this one, you wouldn't actually give it as an ordered pair because it's always x comma y, and I'd have to tell you that the ordered pair is like a comma b or something like that. Yep. So for this one, I'd be totally fine with a is equal to 6, b is equal to -9. Okay, for your homework, let's get a couple things circled. Okay, so you guys, for number 1, could you circle B and D? So number 1, B and D. Number 2, B and D. So 1BD, 2BD, 3AC, 4ABC. So 4ABC. 5, I have A, C, and D. Number 6 and 7A. What I want to talk about quickly before I save the video is let's look at 5D for a second. Okay, so here's how they gave us our two systems, and they say solve by elimination. So they're not giving us a choice, and I wouldn't want to solve by substitution anyways because I can't get one of these in substitution. Now, we have to rewrite each of these because how did I say I want it written? X, then Y, then what's after the Y? Equals, and then a number, right? So for D, I've got my X, I've got my Y, and there's my number. So we've got to bring that -6 over, right? Because we want to set this up for elimination. So what you're going to do for D is you're going to add 6 and you're going to add 6. So my first system is 3x plus 2y is equal to 6. So I've got my x, my y, my equals, my number. What are we going to do to this system? I've got my x and my y separated, and I've got my number on the right-hand side. What do you guys think I would do here? I want x and y together. So what am I moving? The easiest way to do this is to bring this 5y over here with the x, right? That would be the easiest. Because if you do that, watch what would happen. If you subtract 5y, what your second system is 9x minus 5y is equal to 18. So they want x's, y's, equals, and our numbers lined up. Then you're going to say to yourself, okay, we've got to multiply. You guys, look at the x's for a second. There's something I could multiply this first system by to eliminate the x's. Do you guys see what it is? A 3. Yep. So it would be multiply this guy by a 3. And then you'd eliminate the x's. Yes. Okay, so let's look at 3c. Yes. So you guys, let's set up 3c together. So 3c, they've got your x's and your y's lined up, but they don't have these numbers on the right-hand side. So what 3c would be, the first system would be 4x plus 2y is equal to 31. And the second system, because I just added 31 to both sides, the second system would be negative 4x plus 6y is equal to 13. There's your two systems. You should be able to see that the x's are going to eliminate. You just have to figure out, do you add or do you subtract to get those x's to eliminate? Okay, everybody's good with that?